Okay, now that we know Sn1 and Sn2, we also have to be able to argue what factors affect the rate of nucleophilic reaction. The first is the choice of halogen. If you are haloiodide, you're faster than halobromide, which is faster than halochloride. The simple fact is the strength of the bond. If you look at the bond enthalpy of carbon and iodide, is 238 kilojoules per mole. So it's the weakest in comparison. If you look at cis chloride bond, it's 238 kilojoules per mole. Easier to break, therefore faster to react. The next factor is Sn1 is preferred over Sn2. Why? Because in Sn1 you produce a carbocation which is extremely stable and reactions prefer to produce it. On the other hand, Sn2 produces an activated complex that requires lots of energy because it has high activation energy, and the reaction pathways don't prefer that. The last is choice of nucleophiles. Cyanide is the strongest and water is the weakest in choice. Why? And in each case you have to be able to compare. So if I go after cyanide versus hydroxide, the only argument is charge density. This has higher charge density. So for each one you try to look for an argument that you can win. So cyanide has higher charge density, therefore easier can attack the positive carbon. If you look at, for example, why hydroxide is stronger than H2O, the simple fact that hydroxide is a stronger base will win the argument. So this is a stronger base. So anions preferred over their molecules. Why ammonia is stronger than H2O? The only argument you can win is electronegativity. Nitrogen is less electronegative. Molecules with less electronegative element that carries the lone pair are stronger nucleophile. So nitrogen is less electronegative. And those are good to get your points on paper 2 or multiple choice. So the choice of halogen, we prefer it to be iodide. Sn1 versus Sn2, Sn1 is faster, preferred. Cyanide compared to hydroxide, compared to ammonia, compared to H2O, this is the order. Cyanide is quicker and stronger nucleophile.